here we go. I would say the instructions as to how to proceed are right here. So if you're asked to determine which event is more likely to happen, this is how you would go about it. Okay. So I would say, what's that? 23. Morning, page 23. So this, I would say this chunk, if you can kind of simplify it and have it on your study sheet, 23. That'd be great. So the skill that you need to use here, if you don't already, because it says the best way to determine higher chances is to determine the probability as a decimal or percent. Okay, that's the way to proceed here with these ones. The higher value indicates a higher chance of it happening. So let's say, so let's go with an example here. If you know, you have a probability of 3/7 versus 4/9, and you're like, which one of those two is more likely to happen? Sorry, it's a bit small, right? But 3/7 versus 4/9, which one is more likely to happen? Grab your calculator, and then you just go 3 divided by 7, and don't necessarily round too soon. But this ends up being 0.4286 rounded. Then I'm going to go 4 divided by 9, and that's 0.4444, right? So in this case, between these two, this one is more likely to happen. Not by much, but it is more likely to happen. So that's what's happening here. That's what we're interested in, right? Both probabilities, you turn them both into decimals, the higher number wins. You're saying, hey, there's a higher chance of that happening. But what if you're given odds, right? Watch this. The odds of being attacked by a shark is 1 to 3,748,067. I googled it, so don't ask me how I know those things. Okay. The odds of coming into contact with hornets is 1 to 54,093. State the probability of being attacked by a shark. State the probability, let's highlight that. State the probability of being attacked by a shark. So remember, we have, if you have this number, 1, 2, 3, 7, 4, 8. Don't do the commas, please. I don't really need them there unless there's a decimal. So we have this as our odds. So these would be odds. We're going to turn that into a probability. Okay. So probability of being attacked by a shark would be 1 plus this. You add them up. Okay. 1 plus 3748, 067, right? So you add these two up, that's your denominator, boom, right? Let's zoom in a little bit. And then the top is one of these two numbers. In this case, this number stands for being attacked by a shark, right? Because remember, if it says odds of being attacked, that means that attacked is the first number and not being attacked is the second number. So this ends up being 1 over, and you might think, oh, that's so silly. I'm just off by 1, Mr. Dirksen, right? If it's 67 versus 68, what's the big deal? It does make a difference in this unit, right? So what would that be as a decimal? I don't think the province would ever do this to you, but let's try that as a decimal. 1 divided by 3,748,068. That's a very, very small number, isn't it? But we're going to write it down anyways. 0 point. There are 6 zeros. 1, 2, 3, 4, 5, 6. 2, 6, 6. And if you multiply that by 100, what happens to the decimal just shifts over 2 spots. So you'll be left with 4 zeros. 0.1234266%. So that tells you how ridiculously low the chances are, right? When you do it like that. So we went from odds to probability, and here we have it in 3 formats. Let's do it again for being attacked by hornets. We have our odds that are given, and I would tell you, hey, turn that into a probability. So probability of hornet would be, again, 1 plus 54093 at the denominator, and then 1 goes at the top in this case. That's 1 over 54094. Okay, let's see which one, what that is as a decimal. At 0.0000, so 4 zeros, 18486. And as a percentage, it just shifts over 2 decimals, right? 2 decimal places. So that is your percentage. Let me focus once. It seems like it's a little blurry to me. Why did you pick such ridiculously small numbers, Mr.? Because I still need you to be able to determine which one would be the one that's more likely. And just place values, right? This has 6 zeros, this has 4 zeros, so this is the one that's more likely to happen, right? Being attacked, or coming into contact, sorry. I'm going to erase this. Coming into contact with a hornet. And obviously this would change depending on the season, time of year, blah, blah, blah. But if you just take like the entire year, probably, right? That's the chance any given day. Why is that? Since the likelihood or probability is greater. So I'll say 0.00018 dot 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 is greater than 0.000000266. I want you to try the next example, talking about lates, right? So there we have two students with their odds of being late. Which one is more likely to be late? You can't just guess. I want you to show me the work, right? The work you put in to determine that answer. We're going to correct it, and then we're probably going to start. So Xavier, we're turning that into a probability, right? So that'd be, first thing I want you to know is, right, 4 plus 9, add up these two numbers to get your total. And in this case, it would be 4, right? So that would be 4 over 13. For Nina, it would be 5 plus 14, and then 5 would go on top. And that would be 5 over 19. So let's figure out which one. That's 0.3077. And you don't need to do percentage because I won't, unless I ask you, of course, to turn that into a percentage. So here you have it. So this is more likely to happen, more likely to be late. Voila. See, so it's a bit of reviewing, turning odds to probabilities. And so let me see here. I just want to see what's in store. Yeah, so there's a bunch of examples back here. So I'm going to give you a little bit more time to work on these because after the AC, then I want to touch base on something else yet, right? So how about I'll go to page 24. We're gonna just do A, circle A, circle C. So AC, hey, see, AC, that's it for this page, A and C. Then you go to page 25. And I want you to try this example here with the Spartans, this one. And also down here, this is reviewing odds and probability as well. So just circle that, okay? So the example and that last one all the way to C. Right? So you're mixing everything up, right? I'm mixing everything up as I go along. So try that right now. AC, and then the back side, basically the second half of that page. Okay, let's try that. New, but it expands what we're doing. Which one is more likely to happen? So what you do there is, if at all possible, get a probability. So red sevens, there are 2, right? 2 out of 52. There are 4 sevens in a deck. 2 of them are red. Okay? And then this one here would be, there are 4 jacks out of 52. You know what? If they have the same denominator, you already know that the one with the greater numerator is going to be the winner. But it doesn't hurt. It's still doing it the old way. 0.0385, and this one you get 0.0769, and so this is the one that is more likely. Okay. Draw a face or rolling a 5. A standard die has 6 sides, right? So probability of face would be 12 out of 52. Probability of rolling a 5 would be, there's 1 in 6 chances of that happening. Okay, so this would give you 0.2308, and this gives you 0.1667. Okay, so this is more likely to happen. Not too bad, right? Drawing a club face card or a spinner landing on yellow. So probability of a club face, there's 52 cards in total. There's 12 face cards, right? But club, there are only 3 in the club category. There's only 3 face cards there. So this gives you 0.0577, and the probability of landing on yellow, I think there's only 1, right? Yeah. Probability of yellow will be 1 over 8, because there's 8 possible sections it can land on, and that gives you 0.125. And so this one is greater, right? This is 0.0, this is 0.1. There's a bigger likelihood of that happening. Rolling a multiple of 3 or the spinner landing on green. What's a multiple of 3 again? It means that you start with that number and you go up by that number. So 3, 6, 9, and so forth. But on a die, you stop at 6. You can't go further. So there are 2 options there. So probability of a multiple of 3 would be 2 out of 6. The probability of landing on green, there's 2 sections, 2 out of 8. Right? This gives you 0.3333, and this gives you 0.25. Right? So this is more likely to happen, actually, rolling a multiple of 3 is more likely to happen because it's a bigger number. I need to make sure I make this very clear, right? With decimals, you compare place value with place value. So it doesn't matter how many digits it has. It matters when does it beat the other, at which place value. So you compare the first one with the first one. Oh, this one is bigger, it wins. Okay? So it doesn't matter how many decimals it has. It is the place value. A red card or the spinner landing on red. So probability of red would be 26 out of 52, which is 0.5, right? Probability of spinner red, I don't know. Spinner red would be 1, 2, 3 sections, 3 out of 8. And that is 0.375. So this one wins, right? This one is bigger at the point, right? At the first decimal, this one wins. Okay, I need to make sure you understand that. Okay, keep going. Backside. I asked you to just do the Spartans one here at the volleyball tournament. So the odds for the Spartans is 9 to 17. Odds in favor of the Spartans winning. So odds, you got to pay attention here. I purposely tried to, I really wanted you to think in favor of winning. Okay? So that means that this is winning and this is not winning for Sisler. Okay, you got to watch out the wording there. Then the odds in favor of what? Did you catch that? The odds in favor of Calvin losing. So that means what? That means that this is losing and this is not losing. What do we call not losing usually? Winning. So technically this is a little, came out wrong here. This is not losing or winning. Okay, so for these odds, this is winning, this is not winning. Okay, so you got to watch out there. And DMCI has a chance of winning the tournament 4 or 15 times. So winning 4 out of 15. This is a probability already because it's out of total, right? So which school has a better chance? We're going to go Sisler. The probability would be, remember, 9 plus 17. You add them up, and the 9 represents the winning. Okay, so this would be 9 over 26. Let's turn that into a decimal, 0.3462 if you divide that, right? So park that there. Let's go to Kelvin. Probability of them winning. I'm still going to add the numbers for my denominator. And which one am I going to put on top? The 23 or the 12? I want the 12 to be on top here. Because the way it was worded, this number here represents the wins. Okay? So this will be 12 over 35. And that in turn is 0.3429. Very close. I did that on purpose, by the way. Okay, so Kelvin, we've got that. And then DMCI is probability of them winning is just 4 over 15, which is 26, right? 0.2667. Some of you, if you need to turn it into a percentage, do it, right? Multiply times 100 and get that percentage. For some of you, that helps. But which one has the bigger chances? It's actually Sisler, right? Because it's close to this. So 3, 4, okay, keep going. 6, right? It's higher at the third decimal place. So that's the one that wins here, or more likely to happen. More likely to happen. So I agree. If this one messed you up a little bit, I apologize actually, but it's not a big deal here, right? Today at low risk. The odds of being struck by lightning would be this, right? So Odds of, so that's lightning, not lightning. Okay, say the probability against being struck by lightning. So probability, here's the first step you should be taking. You add them up, right? That's step number 1. And against lightning, it would be this one. You have this number against, right? Not happening on top. So it's 11,999 over 12,000. I'll just leave it like that. State the odds against being struck by lightning. So all you do is flip, right? Flip. So we go 11,999 to 1. So the against being struck by lightning, right? That event that we're after is over here on the other side. So that's what I'm after. Next, out of 850,000 people, how many are likely to be struck by lightning? Likely. Okay. So you need to go prediction. You're making a prediction. So this is probability of being struck times 850,000 people. So what's the probability of being struck? Well, it's 12,000, and instead of 11,999, there's a 1 in 12,000 chance of being struck. Right? There's a 1 in 12,000. You multiply that by 850,000, and you get 70.83, which is approximately 70 or 71 people. That can't be right. That's too scary. Still too many people. But don't worry about how true or how believable that stats is. But we're going to leave it at that.